Okie dokie. This is round 2. Whoa, help. Is this round 2? Yeah, sorry. I was on the wrong thing. Shocker. Okay. So, I quit here, and clearly my voice is not better, but it's never going to get better, so I'm just going to ignore it. So what we're going to do is dig into polar coordinates, and remember what we usually use is XY coordinates, which I feel like you get. Polar coordinates were an R and a theta. So you kind of thought of the paper as circular, and you would go in a certain direction, let's say 30 degrees, and you would go a certain radius out 1, 2, 3, let's say. Keeping in mind that negative R just meant you were going the opposite direction. So, like here, in which quadrant? Now, a lot of people are asking me about quadrants, so let's talk about that. It goes 1, 2, 3, and 4, and they go in Roman numerals because they're fancy. So this is my radius and my angle. So you have to know where 7 pi over 6 is, but you have a unit circle. And so 7 pi over 6 would be right here-ish. But this is negative, so it's actually going to go away from. So it would go back here, 2. If it was a positive 2, it would go towards 7 pi over 6. But it's negative 2, so it goes away, like back. And so it ends up in that top right, and so it is in quadrant 1. So you don't have to like specifically graph stuff, but you have to know where it would land or like what it might look like. Okay, so what I love about this question is it says write 3 other names and then leaves 4 spaces. So not sure why that is, even though I made it. So because it's circular, you can get to points a variety of ways. So this one's at 30 degrees, 1, 2, 3, which is pretty much the example I just used. So that's one way. But you can go to 30 degrees like that, or you can go this direction, which is a negative. So I'm still going to be going in the same general direction, but instead of calling that 30 degrees, I'm going to call it what it would be if I went the other way, the rest of the way around the circle. So negative, because I'm going clockwise instead of counterclockwise. And 330, because that's how far it would be around the other direction. Keeping in mind that these two numbers, 30 and 330, have to add up to a whole trip around the circle. So 360. One's positive because I went up, and one's negative because I went down to get to it. So if you remember, we had 2 R's that were positive, and then we have 2 with R's that are negative. And what they're doing is they're going in the opposite direction so that when you back up, you end in the right spot. So let me see if I can make that make sense. So this was 30, which was my original theta. I'd go straight across from that. And straight across from 30 on your unit circle is going to be 210. So if you go towards the 210, but you want to end up back here, you have to use a negative radius because you go away from it. So here's your 210, but you back away 1, 2, 3 from the origin, and the point would end up where it was before, which is what we're trying to do. But again, if you want to call this 210 from the positive direction, you could also go this way the rest of the circle. So it would have to be negative because it's going the opposite direction. It's going clockwise. And you're still trying to get to 210. So you would go 150 because they'll total 360. So you end up with 2 that are going to have positive R's. And then their 2 angles have to total 360. And then you'll end up with 2 that have negative R's. And their 2 angles are going to add up to 360. But you're going to be going away from whatever these angles are instead of towards them, like when the R is positive. So now our verb is to convert. Okay, so you have to know your conversion factors. Rectangular is the good old XY that you've known and loved since Algebra 1. This is an r and a theta. I know it's polar because it has brackets instead of parentheses. So if I went back in my notes and then therefore put them on my cheat sheet, to find the x coordinate, I take r times the cosine of theta. And to find the y, I take r times the sine of theta. So in this case, my x is going to be 5 times the cosine at 210. Now you can use your unit circle for this because it'll probably be a radical rather than a decimal on your test. You would write your answer like that. So 5, and then I go to my unit circle. Cosine is x. So I go to 210, I find the x, and I go, okay, that's negative root 3 over 2. Well, when I multiply that by 5, which is 5 over 1, the tops multiply to become negative 5 root 3 all over 2. They don't actually multiply out. And then to find my y's, I'll be doing this the same, except I'll take 5 times the sine at 210. So the sine at 210 is going to be negative 1/2. So that would mean 5 times that is going to be negative 5 over 2. So that's my conversion. So this is something that I need to know and probably would put, well, for sure, would put onto my sheet. This also says convert, but the difference is this one was from polar to rectangular, and here's rectangular to polar. These questions, you guys, literally go right down that yellow sheet. So if you take out your yellow topics sheet and you put it in front of your face, I'm going to be going right down that list and showing you a problem for each one. Okay, so to find polar, I need r. And if I go back in my notes, because keep in mind, graphing this xy point they gave me, I don't know, root 2 to the right and then down root 2. So I end up here-ish. I don't really know where that is in terms of a number, but who cares? So I'm down here. So think about that. When you go to find your r and your theta, your angle should end up being down there. So how do I find r? Well, I look back at my notes and I find it by doing this. So for me, that's going to be root 2 squared minus, and then a negative root 2. And then squared. Sorry, plus. So when you square this, it's going to be, oopsies. This is going to, when you square a square root, it just becomes that thing. So like when you square the square root of 2, it becomes a 2. And same thing here, negative cancels when you square it. So I end up with the square root of 4, which is 2. So when I go to write my r, I write 2. So apparently, to get to this point, I'm going to be going 2 out. We just now have to find the direction. And direction is going to be theta. And if this is my notes formula for finding r, my notes formula for finding theta is going to say tan inverse y over x. But this is where you have to think about that whole sunny side business. So if your point, polar and vectors both, if you're going this direction, you're going to just use the calculator's theta. If you're going this direction, you can still use it, but it'll be a negative number, but I don't care. We had to change it when we did IXL, but this is not IXL. You're welcome. If, however, you have stuff going off this direction, your calculator is not going to give you those numbers. It only chooses numbers from over here on the sunny side. So here, whatever you get on your calculator, you add 180 to it. And same thing down here. So a little sketch like what I did over here helps me out, because then when I go to my calculator and I do tan inverse of, and I'm going back to my point, the y over the x. Now that looks tricky, but keep in mind anything over itself is a 1. So I'm going to have negative 1 here because root 2 over 2 reduces to 1. So if you go to your calculator and you go inverse, tangent, negative 1, it gives you the angle negative 45, which is actually your direction, because looking at the picture right here, it is a negative 45. That is the angle measure. You're going down 45 to get to that spot that you initially described in X's and Y's. So those are your two methods of converting. So I want to know this and how to use it. I want to know these and how to use them. And I want to have an understanding of when and how to use that concept. Okay, now I wrote over my instructions, so that's super helpful. Use my knowledge of vectors. Awesome. Hopefully I have some to answer the following questions. Okay, so this is very similar, you guys. Now we have these pointy things on the ends that indicates vector, but this is still the X and the Y component. That's why it's called component form. So it's telling me to go 4 in the negative direction. So 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6. And that's describing the end. So the vector actually would look like that. Remember, they're arrows. So that's the vector they're describing. And that is in quadrant 1, 2, 3. Okie doke. Here I have to get it into component form. And so that, keep in mind what that's asking you to do is go from 0.25, so 1, 2, 1, 2, 3, 4, 5, to this. This is your start, this is your finish. So I'm going to negative 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7. So my vector is going to go like that. Maybe not have that big of a blobby end, but okay. So it wants it in component form, meaning how far left and right and how far up and down. So I'm expecting a negative X and a positive Y to get up to that. So what I do is I go back to my initial points, 2, 5, and then negative 3, 7, and I subtract. So I'm going to take that second X minus the first for my X component, and then the second Y minus the first for the Y component. So that gives me a negative 5 and a positive 2 as my component form. So that's my answer. And what that's telling me is that from the starting point, I should go 5 to the left, 1, 2, 3, 4, 5, and then, oops, I copied that as a negative 2 when it wasn't. And then up 2, which seems about right based on the sketch. So I'm pretty happy with that. So really here what I did was I did x2 minus x1 for the x component, and I did y2 minus y1. So it's kind of similar to slope, just in terms of that part. Okay, concepts that come next. Magnitude, direction. This is the notation for magnitude, and direction is asking for the angle. I would like my voice back. So here we go. 2, 5. That's in component form. So it means you're going 2 to the right, up 1, 2, 3, 4, 5. So here's your vector. You are on the sunny side. So when it comes to finding direction, you're going to be good to go. So it's very much like polar. We're using the same kind of concept. The magnitude, if you look in your notes, is going to be the square root of that x part squared plus the y component squared. Now it's going to be written different. It probably looks like this. Vx squared plus v sub y squared. But it's the same exact thing as we did to find r before. So I'm going to be taking the square root of 2 squared plus 5 squared. So that's going to be 4 plus 25, so root 29. And that doesn't reduce, so I just leave it like that. So that is going to be the magnitude. And then it's asking for the direction. The direction is exactly like we did with the polar. You do the tangent inverse of the y part over the x part. So in this particular problem, I would go to my calculator and look for tan inverse 5 over 2. So second tangent, 5 over 2, and it's giving me 68.2. Does that seem like a reasonable angle? Sure does. And I'm in quadrant 1. I'm on the sunny side, so my answer is my answer. and it's 68.1 degree. And this is supposed to say sunny side. Oh, it does now. Yours doesn't. Okie doke. So this is a repeat performance, but here you're going -2 and then up 1, 2, 3, 4, 5. So it's similar but not identical because you are not on the sunny side, and it is your job to go, ooh, when I do my theta, I'm going to have to add 180 to it. First, I'm going to do my magnitude, except when I go to do my magnitude, you realize that you're using the same numbers. You can have a -2 squared, but when you square a negative, it becomes positive again. So they have the same magnitude because they have the same length. They both went over 2 and then up 5. This went back 2 and up 5, but you'd end up the same length or distance. And then when I go to do my tan inverse of my y over x, I get -68.1, but that would be going down here. So that's when I have to remember in my own big brain to add 180. So I just leave that number on my calculator, add 180, and get 111.8 degrees, which actually looks reasonable. If I go back over to my picture, 111 would probably put me about where I drew it. This is going to be my operations, meaning plus, minus, and all that stuff. This was really super easy. So I have to double the numbers in vector v because it says 2v. And then it says minus 3w. So what's vector w? 4, -3. So I'm going to basically distribute this and get a vector that's -4, 10. And here, if I distribute that, I get a -12 here and a +9 here. Why did I write plus sign? Who knows? My daughter's stealing things out of this pantry and she's making crinkly bag sounds. Now she's running for it. So I was supposed to subtract them, but now that I distributed the negative, it becomes adding because you got rid of that negative. So I'm just combining the -4 and the -12 to make -16 as my x component, and the 10 and the 9 go together to be a 19. So I'm just combining them, basically adding. This bad boy is asking me to take the opposite of vector w, which I can't see anymore because I wrote over it. And my vector w is a 4, -3. So I'm really just distributing that. So the opposite would go, like this is saying go right 4, down 3. So my opposite is going to go left 4, up 3. Unit vector. Unit vector is when you do like the little shrinking down version, and instead of keep using the same one so you don't have to do all the math over, instead of going over 2, up 1, 2, 3, 4, 5, that is certainly not 1 unit long. You're trying to find the little teeny tiny one that's the same direction but 1 unit long. So you go and you look up what you have for unit vector, and if you don't have something, you write it down, and you go, oh, I'm supposed to take the vector components and divide each by the magnitude. Okie doke, I can do that. So my vector components are a 2 and a 5, and they're each going to get divided by my magnitude. Well, this vector 2, 5 is the same as it was up here, and I already found the magnitude this time, so I'm not going to redo it. They're going to be over root 29. So I have 2 over root 29, and then 5 over root 29, and I should rationalize each one. So I end up with 2 root 29 over a regular 29. And then here, what I'm doing, if you're confused, is I'm taking this and I'm rationalizing the denominators by multiplying by that same radical. So this will come out to be 5 root 29 over regular 29, because these two, the root cancels out. So that's vectors in polar, which go together, and that's the end of day 1 topic. So the day 1 test is going to be yucky because all that stuff from video 1 and 2 is on it. The last part, part we do on Friday, is, I hope, going to be a lot shorter and easier for you because it's really recent and it's not as many topics. So use the videos, use your brain, use your cheat sheet so that when you go to tackle the test, you can do all of these problems because they're going to be very much the same as what you're seeing here. And you're going to have to know them well enough to kind of walk your way through it at a good pace. Okay, hope that helps. Bye, guys.